This is about as haphazard as a video of mine gets. But this past week, I was involved in a workshop for a bunch of my coworkers who were learning how to install a wide variety of primarily European style pocket door systems. These are pivot and pocket doors. And it required the drilling of a lot of 5mm holes to use with these 5mm Euro screws. These are wonderful screws. If you're working with particle board, they're the perfect screw. But the challenge is your holes have to be accurately placed and they have to be the correct depth. Now, too deep is actually fine. Too shallow is a big problem. And you might see these being used on, these are hinge mounting plates that might be mounted on a cabinet. In the 32mm system, you actually have a series of 32mm spaced holes. In fact, here's a jig that could be used to, commercially available jig, that could be used to drill holes 37mm inset into the cabinet. You'll see there's a pin that stops it at the proper depth. If you have inset doors, you actually use the head of that screw as your stop to stop you in the right position. Not a bad jig. You use this with any one of the I guess you'd call them self-centering drills, very similar to a VIX bit. This is one I picked up here recently, and you can see that they spin in the jig while you drill, and this way you're not actually drilling the jig and damaging the jig over time. But if you're going to be drilling freehand, which we were doing, we were measuring markets, following plans, it became a real problem getting the holes in the right position. And so I wanted to run through a couple tips for you that you might find handy. First off, my favorite tape, I have a bunch of them, and you guys saw that I bought this one that I've been trying to use, and it's driving me a little crazy. This is a metric tape that's got all kinds of interesting features, but so far I'm not in love with it. But my go-to tape forever has been the Pro Carpenter from FastCap. It's a 12-foot rule, so it's relatively small, fine for a woodworking shop. And what I like most about it is it has both inches and millimeters. And if you look, there are these little black diamonds every 32mm that you can use to lay out 32mm spaced holes, as I have here. I measured in 37mm, drew a line, and then measured 32mm spacing. Just to be on the safe side, what I typically do is I use a punch to make sure that the tip of my drill bit is going to go right where I want it. It gives me something physical to interact with the tip of the brad point. And, my eyesight is not what it once was. A punch like that comes in very handy for that. Also, I'm going to mention this. You can also buy masking tape that has both inch and millimeters measured out on them. FastCap makes, again, a great one for 32mm spacing, but you can stick this right onto your project, and it's great for jigs and fixtures, but also for laying out measurements. The 32mm one from FastCap is ideal for holes like this. All right, so then the question of what do we use for stops? I've got a variety of them here. This is the one that all of us have used, and actually it can work fine. We put this in our drill, and I typically am using a brad point drill bit so that the tip of the brad point is going to go right in where I just punched it. And I'm going to drill until I see the shavings appear. And then when I see the shavings getting wiped away by the little flag there, that's when I know I'm at the proper depth or close to it. So right about there. You have to be careful because the chips do want to build up in the flutes here, and they do want to push the tape. Of course, hitting the wood with the tape also wants to push the tape. Another method that works superbly here on the Craig jig is Craig recently introduced a brand new style of stop collar, and they're marking on their drill bits where you would position this for different thicknesses of wood. So a little window there in the collar and then the set screw that locks on. Why this works so well is in part because we're locking on the shank, the part that is cylindrical. The problem is when you're clamping onto the flutes or onto the area actually between the flutes, that's where things get challenging. So here I've got, for example, two different stop collars. They are different diameters on the OD, and they're also different heights. I like a taller stop collar because it interacts with more of the flutes. So give you an example of this. So this is a 5 millimeter drill bit. You can see up here on the shank, it's actually pretty tight or pretty perfectly fit. But then when we get out here, because those flutes are there, it is prone to wander. We want to make sure that we tighten the set screw down onto what is called the land. And we also have to have the correct wrench to do this. Guess that's the other challenge. And there we go. The other thing that frustrates me about these is once you get those tight, they're often cocked, and that might throw off your depth. So you want to do a trial run and measure the depth of your hole. Another kind of stop collar that I do like is a split stop collar. As you see here, it's got the bore that we're looking for, a split cut in it, and then a cap screw that's going to pull it tight around the flutes. And I was drilling with this one recently, and it works great. Now, one of the challenges that it has is it's black oxide, so it wants to leave a mark on the surface. Now, this is nasty melamine, so forgive that. But with this, what I do is I just put a little piece of fast cap edge banding on there. But ideally, you could take a fast cap cover cap and stick it on there, and now you've created a nice PVC surface that's going to slip and shouldn't mar the surface. So let's drill this one. Challenge with these is you do have to keep the flutes cleaned off as you're drilling, otherwise they'll want to get clogged. A couple other solutions I wanted to show you. This style of kind of universal stop has been around since, well, I remember these when in the 70s when I was a kid. They were sold by a company called Arco. I don't know if Arco introduced them or not, but that's where I first saw them. What you have is two plastic body parts that go together, and then in between you've got a collet, and it's a double-ended collet. And as this tapered end is driven into the tapered socket, it forces the collet to close. Likewise, the same thing's happening over on this end, and in theory that will grip your drill bit. I have found that is a lot of theory. It can work, but unfortunately, there are a couple sizes of drill bits that fall in between the capacity of these two, and those are sizes that I use frequently, such as 5 millimeter. So what I've done with this one is I've taken a 5 millimeter drill bit. Actually, I think I took a 4.5 millimeter drill bit that I had. I put it in here, I clamped it down on it, and then I ran the drill and let it kind of chew up. But when you put these in, typically, because it is just nylon or plastic, I put them in from the end that doesn't have the tip and get that threaded through like so. And then we can bring it down and then tighten it at the depth that we are desiring. And that actually has worked pretty well. And that is on there good. Now, recently, some new ones have shown up on the market coming out of China, and I love the looks of these because they are anodized aluminum. Inside, they also have a little nylon collet. So I thought, well, these were promising, and I'd like to try those out. The problem is the small one has an even smaller opening than the plastic one here. So it's of even less use. And again, the sizes that won't work between these two are the sizes that I use. So thank you very much. I might find a need for these, just not on any project I'm working on right now. One more method that we can use for setting the depth on a drill bit is simply using a block of wood or a dowel that we drill a hole through. You can do this in the lathe, you can do it freehand, drill press, whatever, doesn't matter. I put, again, a fast cap cover cap on the end of that for the same reason. Actually, in this case, the wood will burn if you're not careful. You can cut these. In this case, I've got a hex shank on this drill bit. So I cut this on the bandsaw to the length that I needed, knowing that I would leave the proper amount. But you can actually cut these just a little bit shy of your actual depth. And then in most cases, you can stick your drill bit deeply into your chuck and then pull that down and measure and make sure that you're getting the length that you need. If you need to, you can pull it out a little bit and then slide that piece back. So I have several millimeters of adjustability using that method. And again, we'll just drill our hole till we hit the stop. And we're seeing the pencil. Works great, inexpensive, easy to do. Now, since we're talking about Euro screws here, let me show you one of the dangers of not setting your depth properly and drilling too shallow. If I lay this up against the screw, I can tell that I'm a few millimeters too shallow with this. And let's drill this hole. And then we'll drive a screw. Screw looks like it went, or the hole looks like it went into the correct depth, so that's good. By the way, I'm using an absolute bastard of a Euro screw. This is a Euro style screw with a Phillips drive. I did not intend that. I like posi drive screwdrivers for Euro screws, but this is what was available. So I am right now hitting the bottom of that hole. And if I'm not paying attention, or maybe I'm driving this in with a cordless screwdriver, it's possible that as I tighten this thing down, it'll just erupt because it's hitting the bottom. It'll cause everything here to bulge and break. So it really is important to drill Euro screws to their proper depth. Okay, let me show you one more thing that I learned from my dad, and this might be an old trick that everyone knows, but if not, you can pick up faucet washers very inexpensively at the hardware store and just pick up an assortment of these. And these can be used in a pinch as stops. So I'm going to, in this case, chuck my drill bit way, way up on that, and I'm better off, again, feeding these from the bottom. Here we go. And the diameter of these you can select at the hardware store. But you can see we can load these on. And would I do this as a rule? Heck no. This is just something that you can do if you're in a pinch and you just need to get the job done. All right, so see there, we've got a stack. I'm butting this up against the chuck so that I have a firm stop here. And let's just drill a hole to stop. All right, it works. It's weird, but it works. One last thing I want to show you, and mostly because I'm really disappointed in this. I bought this quite a while ago, and my intention was to use it and perhaps to recommend it. And now I can firmly not recommend it. I thought that maybe this would be good for setting the collars on the drill bits, especially because this is metric and that's what I'm using quite frequently. I can use it for angles and blah, blah, blah. No. This thing immediately hit the floor and the front end got dingled on it. And I have found that it's not entirely accurate, which doesn't make sense because of the way it's made. It's extruded, and I believe it's laser engraved. Yeah, it feels like those are indented. I wanted to like this thing and recommend it to you, but I would say avoid this one like the plague. All right, looking forward to your questions, comments, cheap shots, and forgive me for this being a weird one. Make it a great day.